let's talk about a very important topic if you want to be a great programmer, and that is called debugging. You see, nobody writes perfect programs. It's honestly impossible. We're always going to make mistakes, and programs are constantly being improved. We constantly improve our code as we find more and more mistakes. Because programs are full of errors, or what we call bugs or exceptions at runtime when the code is running. You see, the act of finding and removing these bugs or errors from our code is called debugging. And a big chunk of our time as programmers is debugging code, whether it's our own code or other people's code, and figuring out, hey, how come this doesn't work? And the senior developers are really, really good at debugging. So let's talk about in this video about some of my recommendations for debugging and what some good practices are. Now keep in mind that you get better at debugging code as you code more and more. So the best thing you can do is to just keep practicing, keep writing Python code. So what are some of my tips? Well, first, you definitely want to use some linting. And what is linting? Well, we've talked about it, right? When we set up our developer environment. Linting allows us to detect, as we code, some issues with our code. For example, if I do num plus 4 here, and I get a red underline, and you see here that the pyflakes linter notices before I even run my code that, hey, there's an undefined named num. So linting allows us to find these errors before we even run our code. And we saw that we can use IDEs like PyCharm that has linting already built in, or use Sublime Text or Visual Studio Code and install packages and extensions like PyLint to actually have linting in our code. That is a really, really important tool. Next, I recommend always using some sort of an IDE or editor. Because these editors and IDEs, especially the ones that are specific for Python, like PyCharm, have all these built-in tools for us to use, such as auto-formatting based on PEP 8. Remember the official style guide that the Python community has? It allows us to detect errors in our code with, let's say, highlighting and formatting of our code. So it becomes easy for us to detect any errors before we even run the code. Finally, you want to be able to learn to read errors. And this is something that I try to practice with you as we've learned Python. For example, if I do 4 plus, let's say, gibberish here, and I click run, right away I see, hey, on line 6, there's an error in my main.py file. There's a type error. And I see here that I'm trying to add int and a string. So we're able to read errors and understand what they mean. Maybe I do something like this. If I click run, I get a syntax error. And a syntax error, I know, means that, hey, Python interpreter is trying to read my code, but what you just wrote is not Python. I have no idea what you're doing. Here, I see that it's end of line while scanning string literal. So I'm trying to read this string, and all of a sudden, the program ends. Like, you're supposed to end the string, remember? So being able to read these errors is really, really important. And we've discussed some of them in this course. Some of the most common ones, like syntax error, where you're just writing something that Python interpreter doesn't understand. We have something like name error, right? Where we use a variable that doesn't exist. So Python doesn't understand, hey, I have no idea what name is. What's the value of name? We have things like type error. That is when we mismatch data type and do, let's say, a string plus 4. We have things like value error. We have things like key error, where we're trying to access a key that doesn't exist, or attribute error, where we're trying to access the method of an object and that method doesn't exist. Now, these errors are something that we've been seeing throughout the course, and we're going to see a few more. I would say that there's about 15 to 20 errors that are really, really common that show up 90% of the time. And if you remember, you can always go to the Python documentation to learn about them. But this just comes with practice. If you see an error that you've never seen before, I recommend going to the documentation and reading up on it. Once you see it, you usually tend to remember when it comes up next. But let me show you my favorite way to debug code. And it's called PDB, or Python Debugger. And PDB is a built-in module in Python, right here. Again, remember, our built-in module are part of the standard library that Python comes with. And PDB is the Python debugger for interactive interpreters. And you can read about it here, but let me show you what it does. You see, PDB is extremely useful because it allows us to interact with the code. So previously, when we had a function, let's say we have function add, and we have num1, num2, and then this function simply returns num1 plus num2. Now before, if we wanted to, let's say, debug this code, and let's say we're adding 4 plus some gibberish, and it's giving us an error, the first step that I would take is most likely adding a print in here. So I could say print, hey, what's going on? Let me see num1 and num2 and what it's giving me. And print is a really, really quick way and easy way to debug your code. I use it all the time. But PDB gives us a little extra boost. So we can use it like this. We simply import PDB, and instead of using something like a print function, we can simply say, let me add a space in here. We can simply say PDB for Python debugger, and then say set trace. And set trace, I would say, is the most useful method that we have on this PDB object that we imported. You see, when I run set method, it now gives me an interactive Python debugger that I can now type commands in here and actually test out my code. And here's the interesting part. Right now in this PDB, I'm right inside of line 8. So my code tried to run, but then it paused as soon as it said PDB, set trace, and now I'm in this world. And I can test out what's going on. So I can actually say, hey, num1, what is it? Well, num1 is 4. What about num2? Well, num2 is a string, and I could be like, oh, I'm trying to add a string and an int. This doesn't work. So I can detect errors this way as well. Now, this PDB interactive actually has a ton of useful things. So if I type in help here, you see that I have commands that I can use in the PDB. So I have a ton here. I have exit, which I'm assuming is going to exit me out of this PDB, Python debugger. But I also have things like, let's say, list. Let's see what list does. So when I type in list here, and right now the website is really not showing me too much, but hopefully you can still see list. And I get some sort of an output. I see that I get a list of my code, and okay. Let's say I don't know exactly what list does. Well, PDB allows us to type help and then list. And when we do that, it actually gives us the documentation just like we have here. If we go to, let's say, list. Let's see, list. Right here, it gives me the documentation right in here. So it says list source for the current file. Right, so it just lists the source code that we wrote. Okay, that's cool. What else is there? Well, we also have something like step, or S for short. And step is really, really cool. Let's actually use clear to bring this up to the top. So I'm going to say clear so that it clears all breaks. Let's make this a little bit bigger so you can see. There you go. That's better. All right, so now I can actually do something like step. And step is going to allow us to go to the next line. So again, if we make this a little bit bigger, step is going to say, hey, go to line 9. So let's see what happens. I'm going to type in step. Oh, and I got step twice, so let's write step. And look at that. I go to the next line in my code, and it gets me, hey, you get a typo error, the error that we got. So let's add another line in here. Let's say that we're trying to add 4 plus 5 in here, or 4 multiplied by 5, and assign it to a t variable. If I stop this and run this again, I'm now inside over here. If I type in t, I get a name error. T is not defined because, well, I'm inside the code here on line 8, but we haven't ran line 9 yet. So let's do step. And now I'm on the next side. So if I do t now, I get, hey, t equals to 20. Awesome. So step, I can step through the code, which is really, really useful. I also have things like continue, which lets me continue through the code until I return something. And I continue and exit out of PDB, and look at that, I get the error. Let's run this again. Another useful command is a. And a actually gives me all the arguments of the current function that we're in. So look at that, I get all the arguments, which again is really useful. There's also the command w, which shows me the context of the current line it is executing. So you can see here where we are. We're in the add function. We called it with these arguments, and we're now about to run this line. And then finally, as we're debugging this, all right, I think I finally see that we have an error. We should have given it a number. So I can now just exit out of here and simply fix this to 5. So now I can just remove my PDB and everything should be working fine with my code. Awesome. So PDB is awesome to step through your code and debug and try different things. It does require a bit of practice, but after a day of just playing around with PDB, you will become really, really good at debugging. So after this video, I recommend that you write PDB, and hopefully you have a large enough Python file that you can just step over and experiment with different commands using help, using list to see what you have available to you. I actually want to show you one last thing. So let's say we go back to our code, our PDB set trace. I click run. Could I do something like this where I notice that I type A and I have, all right, my code is working, but could I change num2 to now equal some gibberish? Well, let's see. If I do next now, and let's do next to run this final line, I get an error. So I'm also able to change variables in here and write Python code to perhaps test out my functions. This is now working. I can test out, hey, what happens if we change this variable to another value? Again, very, very useful.